Hi everyone, today's solely to a question called unique passes. So in this question, we're finding the numbers way to go from the top left corner to the bottom right corner in this n by n grid. And we can either move down or move right at any point in time. So let's check example 1 to see what the question means. For example 1, we have this robot uh, on the top left corner and this star on the bottom right corner. So we can, one way to go from this robot all the way to the right and then all the way down. And the other approach is to go all the way down and all the way right. And there are other approaches also. So maybe you can go here, go here, go here, go here, and then go here. Or maybe you can go here, and all the way to the right, and then go down. So how can we solve this problem in an efficient manner? So let me use a simple graphical representation on the right side to help you understand. So let's say our row and columns are both equal to 3, then what will happen? So let me draw a grid, 3 by 3 grid, add it here. Okay. And for this top left corner, let's use this person for the start, and the bottom right corner, so just use this start for the finish. Okay. Now let's use a different color. Okay, one to go on this person. So there are two ways: one to go right, and one to go down. So both for this point and this point, we have one way, right? So I have one here and one here. Okay. Now I finished this 2 point. So I consider how to get this point, right? And for this point, we can either go from this point and go down, or this point and go right. So there are 1 plus 1, total 2 ways to reach this point. And now let's also consider this point, which is at the same row with this point. And for this point, well, the one way to go from this point go right and go down, right? So here we have one way. The other way is to go from this point directly to the right position. So you see this point we have 2 way, right? So going from this to this also have 2 ways. So eventually arriving this point we have 3 ways, which is 2 plus 1. So we have 3 here. Okay. And after that, let's consider this point. Well, this point is similar to this point, right? Because we can either go here to here, so one way, or go here to here, so yeah, 2 ways from the point. And then we'll plus 1 and 2, so get 3. And finally, let's consider how to get this star. Well, for this star, we can either go from this point to this point, or we can go from this point to this point. So 3 plus 3 is 6, right? And the final thing we want to do is return this 6, which are result. Okay, so you see the intuition for this problem. So for any row index and column index, we have to consider all row index that's smaller or equal to that row index, and that we only consider the formal column. So for example, let me use a different color. It's green color here. If we want to arrive at these two, we only need to consider this person, which is 1, right? So this one, and add them together. And how about these 3? Well, for these 3, we only have to consider this one and these 2, right? And add it together. And also, for these 3, we only need to consider this one, and this one added together. And finally, for these 6, which are our result, we have to consider this one, these 2, and these 3, right? Which is just adding up all results from the previous column and all formal row indexes. Okay, now I have the graphical explanation and the formula. So let's solve this encoding part. The first thing we have to initialize a DP array with a length of the column, so length of n, and the value should initialize 1 because at least one way starting from the beginning. Okay, then I want to traverse all rows all the way from 1 to m, and j from all the columns, so all the way from 1 to n. Then want to copy paste the formula, but here slightly change, so dpj plus equals to dpj minus 1. Okay, so this means at specific column we have to consider adding up all the possibilities all the ways from the previous column. And finally, we turn the last element on the DP array and we get the result. Okay, see the time capacity memory used to use this solution is quite efficient, right? And I think the code is very short and easy to understand. If you find it helpful, please like this video and subscribe to my channel. Thank you for watching and see you next time.